So good morning students. So today we're going to solve question 11 of GATE CSE 2024 set 1. In this question it states that a function f of x is equals to max of x comma x cube, and this function is defined for all real numbers with a domain as R and a range as R. It means that the function f of x takes value x which are real numbers and gives out values which are real numbers. Both are real numbers, right? And we need to find the set of points for which f of x is not differentiable, right? What does it mean that a function is not differentiable? A function is not differentiable at a point if there is a radical change in the slope. I mean, I can show you how that is visible on a graph. Suppose that a function f of x goes like this and then changes like this. The slope at this point is clearly positive. The slope at this point is clearly negative. Slope, you know now, slope is defined as the angle. If this is the angle that a line is making with x-axis, then the slope of this line, this straight line, would be tan of x, tan of theta. If there is a curve and I take a tangent across this line, and this is theta, so at this point its slope would be tan of theta. This is how slopes are defined. So if there is a radical change like this, then it is not differentiable at that point. So how can we find radical changes in f of x? By graphing it. There is no other way. So let's do that. So we are given that f of x is equals to max of x comma x cube. If this was a differentiable function, we can deal with it in formulas. We would have directly differentiated and then found the points of discontinuity, but we cannot do it that way, because obviously if that would be very simple. But as max does not have no defined way of being handled by the differentiation operator, I don't know of any. So we have to graph the whole thing and then get the answer from that. So we will graph first x, then we will graph x cube, and then we will think about how to approach the problem. Let's graph for if f of x were to be equal to x. In this situation, the graph is going to be like this. It's a straight line graph, right? Let's graph for f of x is equals to x cube. For this, it will be like this. This is the graph of x cube, right? It is now if you were to observe, if we to place this point like this, at some places x is greater than x cube, at some places x cube is greater than x. Same is here. At some places your x cube is greater than x, at some places x is greater than x cube. So from these two graphs we can get this graph by looking at which particular curve is above the other. We can draw the answer curve, and that would be like this. This will go straight, then this will go like this, because this thing is greater than, and then this thing is greater than. Then we have this curve, then we're going to have this curve. So it is clearly visible that there are radical changes in slopes at this point, and this point, right? So how can we find out these points? Well, we know one more thing by looking at the graph, that at all these three different points, both of the curves are connecting, are intersecting, right? So if they are intersecting, we can directly calculate it by equating, let's take a different variable, taking y as a variable. Y is the quantity at which both of the curves meet. This is the assumption. And with that we can take y, feed it into x. We have y only. Then take y and feed it into x cube. We have y cube, and equate both of these. The solution to this equation would give the points at which the curves will meet, because there is no other way, right? Because x cube, whenever x cube is equals to x, that is the point. That is by definition the points at which both of these curves meet. So let's move ahead and What is the solution of this? Y is equals to y cube. If you take y is equals to 0, both LHS and RHS become 0, and that is a true statement. Hence, that is also a solution. So y is equals to 0 is a solution. Once we acknowledge the solution, we can divide both sides by y and remove that possibility. So 1 is equals to y square, right? If we take root on both sides, we get y is equals to plus minus of 1. Plus, you understand why does a minus is also present, because if y were to be minus 1 square is also 1. So that is also a solution that we have to consider when we take root like this. So from this analysis, we have 3 points. Y is equals to 0, minus 1 and 1, at which the curves intersect, and from the graph we know that these 3 points are points at which the function f of x would not be differentiable. So let's see if there is an option of this sort. Yes, D is an option of this sort. Minus 1, 0 and 0. Minus 1, 0 and 1. So hence D is the correct answer. Hope you like the video. Thanks for watching.